earth, water, air, and fire. And by combining them, you could create everything in the universe. Fire and air creates hot. Air and water creates wet, of course. And although chemistry class would have been a lot easier with just 4 elements, we went ahead and developed to have a lot more elements. And the going theory was that these elements in the periodic table, combining them in any certain assortment, would create everything in the universe. But the problem with that theory was that these elements, the atoms, could be further divided. So now we have 2 theories that explain what's going on in the universe, what it's made of, and I'm going to tell you about them. The first one is the standard model of particle physics, and this is what breaks down the atom. It tells you about matter, about radiation, and how they interact. And the other one is Einstein's theory of general relativity, which tells us how matter curves space-time and how matter moves in space-time. Now the thing is, the issue comes up with when we try to explain what we see in the cosmos with these 2 theories. It just doesn't work. Our expected from the theories is different from the observed. So one of the main instances that we see this in is the spin of galaxies. We can see the matter, we see the planets and the stars, and we expect there to be less gravity as you move further from the center of the galaxy. There's less of a gravitational pull, so the objects start moving slower and slower, but what we see is it's moving much faster than what we're expecting. So there's much more gravity than what we expect there to be from what we can observe. So we've got to go back to our theories and revise one of them more and more. And some scientists attack gravity in a theory called modified Newtonian dynamics, which is a crazy theory to wrap your head around, but they're saying that the constants, the universal constants we use to understand gravity here are different in different parts of the universe. And other scientists, they leave gravity alone, they leave Isaac Newton alone, and they say something's wrong with our understanding of particles, something's missing. There's some matter there that we can't see. And this excess gravity is still caused by matter. Matter causes gravity as we understand it, but it's just matter that we cannot see. It doesn't interact with light, it's not recognized by our telescopes. So what is dark matter? What is dark matter? The thing that is important to know is that dark matter isn't a thing. It's not tangible. It's never been observed. It's a theory to explain a gap in our knowledge. Too much gravity, there must be more matter. We can't see the matter. It's dark matter. Now with this theory, everything that we can see, everything that we perceive the universe to be, is only 5% of the universe. And the other is 26% dark matter, 69% dark energy. So with this theory of dark matter, scientists have come up with candidates that could be what dark matter is. And this is defined in certain wavelengths or certain masses. And the project I'm working on investigates axions and dark photons. So we jump into dark photons, and we have the range of wavelengths and masses that define what we are calling a dark photon. And projects, lab groups, start to experiment in certain ranges. And once they perform the experiment, then they can kind of cross off that section. And I'm working on an offshoot of a project called SNIPE, which has already been done before, but we have more sensitive technology, so we're repeating the test, but it's going to go through a longer range. So what does this mean? Well, if we find dark matter, then I win the Nobel Prize. But if we don't, 50-50, then I get to cross off part of that chart that is the unknown and hasn't been tested before, as well as double check those 3 projects that are included. So the theory of SNIPE, which stands for Search for Non-Interacting Particles Experiment, is that these axions decay into dark photons, and then the dark photons interact with the magnetic field. And we would be able to sense these interactions in the magnetic field with magnetometers, which is just a fancy word for technology that measures magnetic fields. But something that really intrigued me about this project, probably one of the reasons why I chose it in the DAD portal, even though my major is environmental engineering, is that civilization, the areas that we live in, have a lot of devices that interfere with the electromagnetic field. Cell phones, telephone wires. So we're taking these magnetometers, bringing them to the forest of Germany. So I see an application, do you want to go camping in the German forest? He's like, yes. So, something else that's interesting about this project is that we're working on a global scale. So we might see some weird patterns in the electromagnetic field that we're sensing, and people might be able to say, oh, that's just that weird place in Germany that you chose that has some pattern. So we have a global network that is performing the same exact test at the same exact time, same day, same time, and you can imagine the irony. I'm from Arizona, so I came to Germany. You can imagine the irony when I found out our collaborating group is in California. But what I've been doing the past 2 weeks is finding an ideal location in this forest. It has to meet certain parameters, be far enough away from civilization, and meet elevation requirements. And then we went out to the forest and checked it out and made sure that it wasn't too close to any walking paths. And then I've been setting up the electronics of the magnetometer. So learning circuits, electronics, how to solder, how to unsolder, all of my soldering mistakes. And something else I've learned, when I looked up SNIPE Hunt to see the previous literature on how the experiment was performed in the past, I found out that SNIPE Hunt is a complete play on words, and it's actually a practical joke or fool's errand in which an unsuspecting newcomer is duped into trying to catch an elusive, non-existent animal called a snipe, or maybe an axion. So when I saw this, I thought, maybe I won't be winning the Nobel Prize this time. If hearing that everything that we perceive the universe to be is only 5% of the universe gives you a little bit of an existential crisis, I completely feel you. But we can focus on the fact that we are one of, if not the only species that is conscious enough and capable enough to even ponder the mysteries of the universe. I'm here researching a subset of a subset of a subset of a theory that might explain a gap in our knowledge, but I am, is here to chat with us. But I am learning a lot, and I get to meet people from all over the world, like you guys, and I'm having fun. So that is what is important, and I hope that you guys are all experiencing the same thing. And with that, we say thank you, or as the Germans say, Dankeschön.